Now we continue with the WASSCE questions on circle geometry, and the next question is from year 2008, and that's 11B. Let's have the diagram first of all. This is the diagram. The question. The diagram shows a circle ABCD with center O and radius 7 centimeters. The reflex angle AOC is equal to 190 degrees, and angle DAO is equal to 35 degrees. Find Roman figure 1 angle ABC and Roman figure 2 angle ADC. How do we go about that? Roman figure 1, we want to find angle ABC. Okay, angle ABC. Oh, that's simple. Angle ABC is equal to, or let me say, reflex angle AOC is 2 times angle ABC. And the reason for that is angle at center is twice angle at circumference. This is the angle at the circumference, this is the angle at the circumference, and this is the center angle that is double this angle at circumference. So that means angle ABC is therefore equal to angle AOC over 2. And we already know that reflex angle AOC is 190 degrees. So that's 190 over 2. And that's equal to 95 degrees. Now to Roman figure 2. To determine the center and circumference angles, you must make sure that the angle at the circumference faces the same side as the angle at the center. You can see that here they are both facing up. They're both facing up. That's the angle at the circumference, and this is the one at the center. So the one at the center will be twice the one at the circumference. Just like this one, this angle too is going to be half of this one. So this angle is twice this. We'll see that in that case they both face down. So let's go to Roman figure 2. Find angle ADC. How do we find ADC? ADC, that's this angle. That's a piece of cake. Angle AOC. This angle AOC. That angle AOC is going to be 360 minus 90 degrees. 360 minus 190 degrees rather. 360 minus 190 degrees. What's that? 360 minus 190. That's equal to 170 degrees. Now, angle ADC, which is this angle, is half of angle AOC. Angle ADC equals angle AOC over 2. Angle at center is twice angle at circumference. This angle is twice this one. So if we want to find this one, we have to divide this one by 2, and that's what I'm doing. That simply means angle ADC equals 170 over 2, and that's equal to 85 degrees. Now let's see what's the next one. Question C says, using the diagram in 11B above, calculate correct to 3 significant figures the length of arc ABC. Okay, the length of arc ABC. Let me even paste the diagram. That's the diagram, the length of arc ABC. How do we find the length of arc ABC? This is the arc ABC. Okay, length of arc ABC length of arc, or let me just write arc ABC, is equal to, the length of an arc is given by the formula theta over 360 times 2 pi r. Now this is the arc, that's the arc ABC. This is the angle it's obtained at the center, and that angle is 170 degrees. We already found that. So that means its length is equal to 170 over 360 times 2 times 22 over 7 times radius, which is, do we know that already? Do we know the radius of, okay, the radius is 7. O is the center of the circle, so radius is 7 times 7 centimeters. And that simply means, let's do that, 170 times 2 times that 170 times 2 times 22 times 7 divided by 360 divided by 7, and that's 20.7778. They said we should find that value, find that length correct to 3 significant figures, and that's simply 20.8 centimeters. And now C Roman figure 2, this is actually C, question C Roman figure 1, and now to question C Roman figure 2. The chord, find the length of chord AD. What's chord AD? Okay, want to find the length of this chord, that's chord AD. How do we find that, the length of chord AD? Let's see that. Okay, if I complete this, that's also a radius from center to circumference. So what do we need? We need to find the angle which that chord subtends at the center of the circle. How do I find? Okay, now if I complete that, if I join O to D, OD is a, then I'll see that OD is a radius. Now if this is 35 degrees, this will also be 35 degrees, and the reason for that is base angles of an isosceles triangle. So angle DAO is equal to angle ADO, is equal to angle ADO. And the reason for that is base angles of an isosceles triangle, because AO is a radius and OA is a radius and OD is also a radius. So triangle AOD is an isosceles triangle and its base angles will be equal. So therefore angle ADO is also equal to 35 degrees. Now that I know angle ADO, I can find angle AOD. So I can say in triangle A, let me call it ADO, angle AOD plus, this is what I'm doing, this angle AOD plus 35 degrees plus 35 degrees equals 180 degrees. Angle AOD plus 35 equals 180 degrees, and that simply means angle AOD, 35 plus 35 is 70, so that means angle AOD equals 180 minus 70, which is equal to 110 degrees. Now we know the angle which the chord AD subtends at the center of the circle, and that simply means we can find its length. So the length of the chord, therefore length of chord AD will now be equal to 2r sine theta over 2, and that's 2 times 7 times sine theta over 2. Theta is the angle which the chord subtends at the center of a circle, and that angle AOD. which is 110 all over 2. And that simply means 2 times 7 times sine 55 degrees. And what does that give us? Let's see that. That's 2 times 7 times sine 55 degrees, which is 11.4681. And they said correct to 3 significant figures, and that's going to be 11.5 centimeters. That's the length of chord AD. Now what's the next one? All right, let's take a breather and then come back for the next. Thank you very much, and I'll see you in the next. Bye bye.